masa kamu, sebab nanti kalau saya tak ajar kamu tak boleh start. So I prefer I teach, you can already start. Okay, bukan saya nak kejar kamu sebab memang benda ni a little bit rush. Okay, a little bit rushing sebab kalau tak kamu tak boleh start. Okay, so next one is kita nak buat process selection. Tadi saya discuss sikit pasal process selection, right? Now I discuss a bit more further about process selection. How do you decide on the process? Okay, so kamu list dulu proses dia, nanti kemudian bila kita bincang, kita akan go through again this consideration. Okay, kalau lebih baik, kalau kamu boleh terus beritahu saya, doktor, proses ni conversion tinggi, conversion rendah, bla 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 bla. You can tell me even better, but I understand you got a lot of work. Kamu dah boleh cek pada literature, dua proses tu pun dah okay. We can already start discussing. Okay, so to do process selection, of course, you have to do feasibility study dengan literature survey. Okay, so choice of process tu, as I told you, is very critical at week 3 yang kita akan jumpa Rabu depan, sebab kalau kita tak pilih proses, kita tak boleh mula apa-apa, dan always remember, kamu dah tak boleh go stun kalau kamu dah choose proses tu. Okay, so although the selection can be changed or modified, but this will waste time and waste money. Real practical world membazir masa dan duit. In our design project 1, membazir masa. Sekarang kamu dah lukis diagram tu, nak tukar proses kamu kena lukis balik. So that one takes a lot of time. So janganlah buat benda yang macam tu. So we decide cepat-cepat, kita dah boleh buat cepat-cepat. Okay, so next one is on process selection. What are the factors to consider? Okay, so this is kamu kena ingat bila saya ajar design project 1, saya hanya beri guideline. Okay, so maksudnya saya tak boleh bagi, I will teach you what are the factors that you need to consider. However, you must remember, tak semuanya applicable kepada plan kamu. So kamu kena betul-betul fikir dan decide which are these guidelines relevant to your plan. Okay, so jangan macam fikir banyaknya nak kena consider. Tak semestinya kamu kena consider semua. It is applicable to your plan. And if you ask me, mana nak tahu? I also cannot tell you now because I have to really see your plan and then I will tell you what are important. Sebab tu kamu kena faham dulu general. Masa consultation kita akan fokus lagi, kita akan fikir lagi macam mana dia. Okay, so the factor including build the process satisfy the customer requirement. Maksudnya proses yang kamu pilih boleh tak menghasilkan chemical yang memenuhi your customer need. Okay, most of the time is purity lah. And second is of course the cost. So if you choose a very high-tech process that might give you, let's say, high purity, tapi it's too expensive for your customer. Sebab kamu kena ingat, customer kamu tu beli untuk application dia. So let's say lah, kamu nak jual ammonia kan? Ammonia tu fertilizer, baja. So let's say you choose proses yang memang kamu menghasilkan baja yang very good quality. Tapi your customer cannot afford to pay that ammonia in the expensive price. Sebab dia baja je pun. So you have to consider that who's my customer, apa yang dia nak sebenarnya. Okay, so from there you will know whether your process is suitable enough to satisfy your customer requirement. Next, is it possible to design, construct, operate in a cost-effective and safe manner? Okay, so let's say the process that you choose involve a very high operating condition. So you have to consider, okay, memang tak kata tak baik. As I told you, most of the time memang pilih high operating condition. But if you may avoid, we will try to avoid because again I tell you it involves a lot of other things when we are talking about high operating condition. Next one, design data, technology, fabrication method, material, raw material, all material must be all available. Sebab tu kata, kamu nampak sini, dia kata design data. Maksudnya kalau you know, if you already have from literature, you know the existing process tu, at least you have a reference, you know, for you to start designing your own one, okay? But if you have no reference of design data, you have to start from scratch, that becomes a big problem. Kamu nak decide macam mana tu become a big problem. Sebab tu saya beritahu kamu, look for literature, establish the process that you want, modify from there is actually better or good enough for design project 1. Okay, so the plan designed to operate adequately even when throughput is reduced, output is increased. Ataupun kata lain, plan kamu ni kalau kita upscale or downscale production rate dia, plan tu masih boleh berjalan. Okay, so that's also one factor. And unusable byproduct should be minimized. This is also a factor, katakan proses kamu tu menghasilkan byproduct yang banyak. you may want to avoid that because byproduct is not byproduct is waste, unless you can justify byproduct tu boleh dijual untuk application lain. So there's one group, your seniors group, doktor kami pilih proses ni sebab walaupun ada main product, dia punya byproduct pun kami boleh jual. So kami boleh dapat duit. Okay, so I justify. Okay, that's a good justification. You may choose to process. So sebab tu saya kata, setiap kumpulan, every group will have different justification kenapa proses tu lebih baik. And in design tak ada salah atau betul, kecuali pengiraan lah. Mass balance energy balance tu ada salah betul lah. Pemilihan proses tu tak ada salah betul. Sebab every process will have its pro and con. So I will not tell you, proses ni salah, proses tu betul. Tak. Tapi I can tell you proses ni susah, proses ni senang. But if you still want to do the proses susah, okay je. Tapi konsekuensinya nanti mungkin pengiraan akan menjadi kompleks. But I will not fault you or I will not punish you if you choose whatever process that you want for your group. Okay, so that one I tell you first kan? Okay. Other factor as well. Factors such as, kejap saya tak nampak, utilities such as electricity, cooling water should be available. The plant must run safely, okay? The plants must confront to any environmental protection requirement, any potential future restriction. So sometimes, kenapa ni? Okay, sorry. So you have to also consider, which we will do, safety and environmental consideration. We also will study later. So by right sebenarnya, cara yang betul, kita kena buat dulu semua ni, baru kita pilih proses. Tapi kamu tahu kan, 6 minggu kalau kita nak buat semua ni, baru nak pilih proses, memang tak mungkin lah sempat siap. Sebab tu kita buat serentak. So means kita in tandem pilih proses, in tandem kita juga buat benda-benda ni. Sebab dalam report kamu akan termasuk part-part ni. So by right kena buat dulu part ni baru pilih proses. But due to time constraint, kita buat bersama-sama. In tandem dengan dah pilih proses dan juga kita buat juga part-part ni bersama-sama. Okay, so the plant must be energy efficient, maintenance should be minimized. So these are the general consideration as I told you. But again, of course, it's impossible for your plant to fulfill all requirement. But at least yang penting kamu boleh justify dengan saya dalam report, we choose this process because of this. Tak ada salah, tak ada betul. As long as you're able to justify. Okay. After you dah pilih proses, next, you provide the detailed description which you are needed in the report, the main features and the advantage, disadvantage. So, nanti kamu pilih dua proses kan, kamu kena explain apakah features dia ataupun apa benda kriteria utama, apa part yang utama dalam proses tu. Biasanya reaction lah kan. And advantage, disadvantage. So you must able to discuss, okay, you must be able, consultation minggu depan kalau kamu dah boleh beritahu saya ni lebih baik. Okay, kalau kamu tak boleh beritahu pun tak apa. Tapi dalam report tu kamu kena fikir kemudian kebaikan keburukan proses ni, then only you will then tell report what process that you choose. Next one, obtain PFD or PNID. Sebab tu saya kata by Wednesday depan kalau boleh dapatlah daripada teacher PFD, proses yang kamu nak. Kalau tak boleh pilih untuk dua proses tu pun, pilihlah untuk proses yang kamu nak tu. Kalau kamu dah decide sebelum jumpa saya pun okey je. Okay? Kalau kamu tak boleh cek dua-dua, cari untuk proses yang kamu dah decide tu, kamu rasa macam group member dah setuju kita pilih proses A, kamu boleh tunjukkan saya PFD tu pun dah okey. But the better will be kalau kamu boleh tunjuk untuk dua-dua proses lah. But if you cannot, one also okay, but for the process that you want. PFD dah cukup. PNID terlalu kompleks. So PNID sebab dia dah campur piping and instrumentation part. So a bit complex and you will get very headache. A bit confused kalau tengok PNID. Tengok PFD is much easier for you to realize, to understand. Okay. Next one, all detail relevant publication, available data means by the time kamu jumpa consultation tu, hopefully cukuplah information untuk kita discuss. Next step, by right. This one minggu keempat lah, minggu ketiga tak mungkin. Minggu keempat, kita kena start draw block diagram. Okay, for each flow sheet to show the main and chemical engineering plan to provide initial comparison of different processes. Okay, by right. Daripada literature tu, kamu kena draw block diagram sendiri untuk dua proses dan kita pilih satu. Okay. I try to save you time. Minggu depan kita dah pilih proses tu je kita akan buat block diagram. So minggu ketiga pilih proses. Minggu keempat kamu dah kena tunjuk saya block diagram. I will teach you apa tu block diagram. Kenapa? Dalam block diagram tu, dia ada block tu kotak. Setiap satu kotak tu mewakili satu equipment. So katakan kamu tunjuk kat saya 20 blok, 20 kotak, maksudnya 20 equipment. Tak boleh lah, saya kata kamu janganlah. Okay, so normally rule of practice, rule of thumb, saya nasihat student saya, janganlah bilangan equipment termasuk pump, termasuk all auxiliary, heat exchanger semua, 10 ke 20 equipment dah cukup. Don't go more than 20 equipment. More than 20 equipment memang jangan. Okay, so setiap blok tu mewakili satu equipment. So I can tell you, okay, kalau kamu proses ni kan, block diagram ni kan, ada 10 kotak, 10 equipment. Okay lah. So kalau tiba-tiba tinggal 20 kotak, because you don't forget, kotak tu tak termasuk pump, heat exchanger, expander semua tak termasuk. Compressor tak termasuk. Dia just main equipment. So kalau ada 10 kotak, campur utilities lagi katakan 5-10 lagi 20 equipment okey. So kalau dah 20 kotak campur utilities 30 kotak 30 equipment cannot. Okay, so that's also, tapi block diagram not this stage. Block diagram week 4 I will tell you to do block diagram. Okay, so next advantage, disadvantage. So you can tell me in general, doktor, proses ni dia punya kebaikan, ni kekurangan dia. Proses ni kebaikan, kekurangan dia. You can just tell me, dan tak tahu pun consultation tak apa. Kalau boleh, beritahulah. Kalau tak boleh, tak apa, but report kena ada lah. So advantage, disadvantage ni general. There are a lot of things that you may discuss. Raw material, process, condition, a lot of things that you may discuss. Okay. Next one is production stage. Okay, so production stage ni, as I tell you, general dia macam ni. Reactor, reaction, separate, purification. Ketiga ni memang tak boleh escape. Dalam setiap chemical plant, walaupun betapa beza dia pun, ketiga ni mesti akan ada dalam step yang ini. Reaction, separate, purification. So most of the time, kan saya kata kamu boleh modify kan daripada plant, existing plant kan. So modification tu usually yang ni lah, modified reactor tu. Mungkin kat doktor dia guna satu, kami nak guna 3 bersiri. Ataupun doktor dia guna PFR, saya nak guna CSTR. Apa dia guna ni, saya nak guna ni. Boleh. Next stage, separation. Separation pun you have learned in separation, right? There's a lot of separation equipment. So let's say mula-mula dia guna separator. Separation dia tak bagus. Kamu nak guna let's say distillation column. Boleh je. So you modify. Then next stage, purification, so on. So most of the time, itu yang kita buat dalam design project 1, kita modify sahaja daripada plan yang dah sedia ada. Okay, so maybe normally these 3 stage yang kita akan improve. Even in the real chemical plant pun, bila people talking about designing plant, dia takkan design daripada scratch. Dia ambil daripada proses yang orang dah buat, dia modify je. Dia tengok part mana yang tak bagus, dia modify. Okay, part yang, that part, which is usually these 3 parts lah. Okay. Next one is, sikit lagi purity. So as I told you, purity, kamu dah kena decide purity produk kamu. Okay, of course the decision, kamu tak boleh sebarangan decide, saya nak 90% lah, saya nak 100%, cannot. It must be detected by the customer requirement. So one way, kalau kamu identify customer kamu, kamu dah boleh cari daripada website dia. Tapi most of the time susah nak cari. Sebab tu saya kata dengan student saya, practical way, cari je kat Alibaba. So most of the time Alibaba will have chemical ni, purity apa yang dijual. Sebab most of the time itu yang purity customer dia nak. Sebab tu dia jual kat Alibaba in that kind of purity. Or you can find from other chemical website. So you can find from Sigma Aldrich, you can find from many types of chemical website. But you can see the purity of the chemical tu, kamu akan nampak, kamu akan tahu dah apa purity yang biasanya dijual untuk chemical tu. So you must remember, tak semestinya mesti 100% purity. It really depends on your customer needs. Okay, so that's why purity is always an important part in your chemical plant. Okay, so usually, okay, rule of thumb, kalau produk kamu purity more than 99.5%, kamu dah boleh terima sebenarnya. Tetapi if your purity is low, most of the time kamu akan recycle balik untuk improve purity. So kalau dah capai 99.5, dah boleh dijual. But if you get less than 99.5, you will have to recycle to improve purity. But again, this is rule of thumb ataupun kebiasaannya, tetapi bukan kewajipan. It really depends on your customer needs. Okay, so next one, is on comparison. So this is comparison that you have to consider. Adakah proses kamu high pressure, low pressure, CSTR, PFR, this reactor, high temperature, low temperature. Okay, so ini biasanya yang kriteria yang kita consider bila kita nak cakap pasal proses, perbandingan proses, proses condition. So pressure, jenis reactor, temperature. Okay, kenapa reactor jenis reactor? Sebab ia bergantung. Katakan kalau reaction kamu liquid, CSTR. Kalau gas, PFR. Okay, so kalau campuran, kita kena consider. Kalau campuran tu macam mana? Nak bagi CSTR ke lagi PFR? There's also a consideration. Okay, but again I tell you, dalam design project 1 tak ada salah atau betul. Kalau kamu nak pilih high temperature, saya takkan kata dia salah. As long as you have reason, doktor saya guna high temperature sebab saya dapat conversion yang tinggi. Done, you can accept. You put that in your report, you already get the marks. Okay, so sebab tu design senang sikit. Tulis je. As long as you got reason, dah diterima, tak ada salah betul dalam design. Yang salah hanya kalau kamu tak buat report tu. Okay, so that's why I tell you design, macam mana kamu struggle pun, kamu hantarlah report tu. Kamu tak akan fail. The most also you get B-, but you send the report. Sebab semester lepas ada student yang give up. Actually design, perasan every semester akan ada satu dua student yang akan give up pada stage kedua. Jangan give up sebab as long as you submit report, kamu dah pass. So jangan give up. As long as you submit report, you dah lepas the course. Okay, so I tell you first lah kan, sebelum kamu decide nak give up, jangan give up. Okay, next, equipment list. Okay, so equipment list ni, bila kamu dah decide proses, kamu tengok pada literature kan, so we know dah equipment apa yang kita akan guna. Of course, list ni tak finalize yet because it might change kemudian. Tapi kamu dah boleh identify lah reactor, pump, distillation column, expander, compressor, so on. Kenapa? Sebab kita nak buat cost estimation. So dalam design project 1, kamu dah kena buat sedikit cost estimation. Tapi cost estimation tu hanya bergantung kepada equipment saja. Kita tak consider benda lain. Kita tak consider utilities, kita tak consider benda-benda lain. Kita just estimate cost plan tu berdasarkan equipment. Okay, so we have a rough cost. Katakan kamu kira 5 million. So you know rough cost untuk equipment is about 5 million. Tapi tak termasuk gila construction, bla bla bla. But from the cost of equipment, kamu dah boleh tahu sebenarnya proses tu mahal ke tak. Okay, so dalam design project 1, saya suruh kamu kira untuk satu proses je. Saya tak payah suruh kamu kira untuk dua. Kalau kamu kira untuk dua, kesiankan kamu. So, you calculate for one only. By right, in the real plan, design, kamu kena kira untuk dua-dua. Supaya kamu tahulah, katakan proses A, equipment cost dia 10 million. One more, 1 million. So, kamu tahu proses A tu 10 kali ganda lebih mahal, baru part equipment, belum lagi construction, and so on and so forth. Okay, so that's also something that you have to consider. But in design project 1, kamu kira sajalah untuk proses yang kamu pilih. Tak payah kira untuk dua-dua. Okay, so that also save you time as well. Next one, block diagram. Okay, so this is example. Tapi nanti saya akan ajar kamu satu chapter khas on block diagram. Maybe by next week, saya akan ajar satu chapter khas on block diagram, which we will do in week 4. So, kamu nampak dalam block diagram ni ada 1, 2, 3, 4, 5, 6, 7 kotak. Ini 7 equipment. Termasuk pump, termasuk exchanger, termasuk compressor, it will goes up about 15. Biasa double je. Utilities tu darab 2 je sebenarnya. Biasanya dalam this one, 7 box, 7 main equipment, probably about another 8 or 9 utilities. So, total 15 equipment. So, kamu jangan lupa, setiap equipment tu kena mass balance tau. Setiap equipment tu kena ada energy balance. Okay, so saya kata janganlah buat terlalu kompleks sebenarnya. Okay. So, then, this is what I ask you to do. Cari proses flow diagram kalau kamu boleh. PNID ni kalau tak ada choice lah, dapat PNID pun okey, tapi PNID ni susah nak tengok sebenarnya. Kenapa? Okey. Kalau PFD dia lebih less complex sebab dia hanya ada main equipment, main process piping, a little bit of the utilities and just pressure, temperature. Flow rate, density. Sebab tu nanti kita akan buat ni, kita akan cari pressure, temperature ni kita akan cari, flow rate for mass balance and density. Kalau PNID termasuk yang kesemua di atas dan termasuk pipe, line number, size, instrument, control, utility, line, drain, vent, semua benda dah kena ada dalam PNID. So kalau kamu tengok ini adalah PFD, meaning when you finish your design project 1, this is what you are going to do. This is what your final aim for design project 1. Equipment, okay, equipment design ni semua. Jangan lupa untuk drawing equipment ni kita guna Microsoft Visio. Okay, tak apa. Kalau kamu tak ada Microsoft Visio, tak apa. Bukan kebetulan, UniKL has external license for Microsoft Visio. I will share you later the software punya installer. You install using UniKL license, you may use Microsoft Visio outside of UniKL. Okay, later I will share you when you're using. Tapi nak buat draw ni bukan guna Excel, bukan guna Word, bukan guna PowerPoint, guna Microsoft Visio. Okay, so this is your ultimate aim to draw this. Even this pun saya rasa complex. This is for your senior tau. Ni bukan daripada literature. This is your senior. So you can see actually this is already quite complex. And kamu bayangkan dia kena buat mass balance untuk setiap ni. Setiap satu part line ni dia kena buat mass balance. So this is actually considered quite complex. But to be honest, your senior did this, you know. So it's actually very doable nak buat sebenarnya. Okay, next one. Part design project 2, kamu kena buat yang ni, PNID. Nasib baiklah saya tak ajar design project 2. Saya kesian Dr. Syahira sebab susah sebenarnya PNID ni. So this is what you do in design project 2. Okay, tapi Dr. Syahira is a very good lecturer. I'm sure that she can teach you until you finally get PNID. I will teach you to get anti-process flow diagram. Yang tu saya akan ajar. Sampai dapat process flow diagram is my responsibility to teach. PNID is Dr. Syahira. So you can see, kamu banding pun kamu boleh tengok kan how complex PNID in comparison to PFD. So PFD is just main equipment, temperature, pressure, ada stream. Setiap stream tu ada nombor. Okay, equipment ni, dia punya design ni kamu tak boleh sembarangan pilih. Kamu kena tahu kalau reactor dia bentuk macam ni. Lepas tu anak panah ni tak boleh sembarangan pilih anak panah. Anak panah ni ada juga masuk dia. Dan pemilihan nama. Nama untuk equipment pun ada dia punya specification. Bukan sembarangan nak pilih-pilih nama pun tak boleh. Okay, so I will teach this in chapter 4. Right, so that's all for today. So I take a bit of your time. I teach 2 chapter. Tapi biasa chapter 1, chapter 2 memang saya ajar dalam masa sejam lebih sebab it's quite easy. Okay, so to repeat back, the good thing, hari ni kamu seksa sikit dengan saya. Tomorrow kelas tak ada. So maybe you can use the 2 hours to discuss with your member untuk consultation minggu depan. Okay, so take the 2 hours to consult with each other. Kelas Jumaat as usual. So untuk minggu depan, your consultation homework dia, cari 2 proses daripada literature dan provide as much information as possible yang kamu boleh cari, dan kalau boleh ada proses flow diagram untuk daripada literature untuk proses itu. Kalau boleh untuk dua-dua proses, kalau tak boleh untuk proses yang kamu rasa kamu nak pilih, kamu tunjuk saya proses flow diagram dia pun okey. Kedua, at least boleh beritahu saya raw material dia apa. Tapi kalau kamu tak gerti, kamu tak tahu macam nak baca, share je literature tu masa consultation. I can help to process and look for it together. But you must already decide by next week during consultation on that. Okay, so thank you so much. I see you on Friday for lecture and also next week for the consultation. Okay, have a good evening and have a good rest for tonight. Okay, thank you.